This episode is sponsored in part by StrongDM. Transitioning your team to work from home, like basically everyone on the planet is? Managing gazillions of SSH keys, database passwords, and Kubernetes certificates? Consider StrongDM. Manage and audit access to servers, databases like Route 53, and Kubernetes clusters, no matter where your employees happen to be. You can use StrongDM to extend your identity provider and also Cognito to manage infrastructure access, automate onboarding, offboarding, waterboarding, and moving people within roles, grant temporary access that automatically expires to whatever team is unlucky enough to be on call this week. Admins get full auditability into whatever anyone does, what they connect to, what queries they run, what commands they type, full visibility into everything. That includes video replays. For databases like Route 53, it's a single unified query log across all of your database management systems. It's used by companies like Hearst, Peloton, Betterment, Greenhouse, and SoFi to manage their access. It's more control and less hassle. StrongDM. Manage and audit remote access to infrastructure. To get a free 14-day trial, visit strongdm.com/SITC. Tell them I sent you, and thank them for tolerating my calling Route 53 a database. Back before these unprecedented times struck, my business partner and I hosted 2 Q&A sessions. We were asked all kinds of questions about AWS's multitude of services, which we also answer now, lightly edited, that make us sound way more intelligent than we already did back when we got started. How does RDS pricing compare to other managed database service providers that work on top of AWS or other providers? Do we have any recommendations? So, my default approach here is to first take a look at where the data you're using needs to live. You might not need a relational database at all. We've seen S3 become a lot more intelligent and queryable over the years. While the latency isn't what you're ever going to see around a performant relational database management system, it's certainly not bad, and you can get pretty far down the road with that. When you have to deviate from there into a traditional database, there are a few different things to consider. Firstly, there's the NoSQL option, and DynamoDB is an absolute marvel if it supports your use case. Otherwise, you're going to have to figure out whether to run MySQL on top of RDS, run it on top of EC2, or have a third party manage something on top of EC2 for you instead. My default go-to would probably be to start with RDS because there's a lot of things it sweeps away that you don't have to worry about. And the management overhead costs are generally not significant either. You'll pay for what you use and there's a fee built into it, but you'll understand how it works and how it breaks, which is very important around things like your database layer. The alternative to that is running on top of EC2, which gives you an awful lot of knobs to fiddle with, and it's entirely likely you're going to break things in a massive way. Of course, do it if you need to do it, but do it for the right reason, not that you might have to move to a different cloud provider at some ambiguous point in time, like some ludicrous multi-cloud strategy you didn't think all the way through. The third option is to use a third-party service, something that hangs out either in another AWS account or in another provider, but that can introduce latencies and you won't have nearly the same visibility into what's going on where and when. Go down that path cautiously. That's not to say there aren't some terrific offerings in the space, but now you have something else in the critical path that stands between you and AWS, and that introduces a whole bunch of risk, not just technical aspects, but business risks too. I would want to see a massive capability story here before entertaining this option seriously. Another question was, do you know any good ways of analyzing spend on RDS charged backup storage? So this is a fun one. Here's how RDS charged backups, which is a line item, works. Up to a certain point, they're free based upon usage and provisioned capacity. Then it starts costing you money. But it's not entirely clear where that line is. When you start seeing those fees show up on your bill, it usually indicates something is awry. Maybe you're not aging things out appropriately, or maybe you have 20 copies of something when you only needed a couple, and you can usually chase down what's going on starting with Cost Explorer. Now again, those charges might be an indicator that there's something amiss with your database backups, but there are probably bigger fish to fry in your AWS account unless something is very wrong. I've yet to see a story where RDS charged backups were a meaningful portion of the bill. If you have that, please reach out and let me know. I'd love to see it. The next question we got was, does anyone actually understand Aurora's I/O and how it reduces cost? No, they don't. There's a method you can use to calculate what the Aurora I/O charge is going to be. It's called suck it and see. That's not nearly as scandalous as it sounds. It was the way you'd figure out if a power cable was live back in the day. Of course, you wouldn't actually suck on a power cable to see if it blew you through a wall. That would be spectacularly dangerous. You'd have an apprentice do it instead. It's the same kind of approach here. You end up modeling the use case and seeing what it's going to cost after it's been charged. The reason this comes up is because with the Aurora pricing model, it's 20 cents per 1 million I/O operations. But nobody knows how many I/O operations your database is going to do because an Aurora I/O operation doesn't map cleanly to a MySQL or Postgres I/O operation. A lot of AWS billing models tie directly to things that are impossible to calculate in advance. Tell me to spin up a single web server running WordPress and serve traffic, and I won't be able to tell you what the monthly bill is going to be with any level of accuracy until we start seeing what the traffic to the site looks like. If you're looking to wind up standing up infrastructure but don't want to spend 6 months going to cloud school first, consider Linode. They've been doing this far longer than I have. They're straightforward to get started with. Their support is world-class. You'll get an actual human empowered to handle your problem rather than passing you off to someone else like some ridiculous game of ticket tennis. And they are cost competitive with any other provider out there with better performance in almost every case. Visit linode.com/morningbrief to learn more. That's linode.com/morningbrief. The next question was, are you a fan of AWS config and conformance packs? Have you seen clients use it successfully? Config, yes, especially with some semi-recent pricing changes. It makes it AWS-like in that it's more confusing to predict the cost, but it stopped charging you for a fixed fee per rule, which is handy. I haven't seen adoption of conformance packs yet. Now, to be fair, the reason most people are using config is that you get it for free, by which I mean it's mandatory, as part of Control Tower or any form of organization-wide governance model. The next question was that I'm able to pull the consumption and cost data from Cost Explorer based on a single dimension, for example, business unit, service, or instance. Is there a way to pull this data on a multi-dimensional or hierarchical basis? The answer is no. We solved this problem at the Duckbill Group by ingesting the cost and usage report into Athena and then using Tableau to slice and dice it because QuickSight is terrible. And this has worked out super well for us. If you're looking for multi-dimensional querying and visualization, business intelligence tools are absolutely the way to go. Unfortunately, Cost Explorer doesn't support it. If it did, it'd be an absolutely killer feature. How do I think about storage? We end up backing up machines 4 times per month, and we keep adding space to drives for random customer data. How do I approach this from a policy perspective? This isn't always the right answer, but I'll say it anyway. Store less. In seriousness, there are multiple storage offerings that more or less map across every cloud provider out there: file, block, and object. The cloud collectively took a vote a long time ago, and it became very clear that Object Store was the clear winner and optimized for that. Look at S3, AWS's Object Store. The economics are great. There's no charge for transferring data between availability zones. You get an obnoxious number of 9s of durability guaranteed, and you have a per request charge. So you're spending something like 2.3 cents per month per gigabyte versus 10 cents per month per gigabyte if you were to instead store that same data on a GP2 disk volume. But wait, the economics of block storage volumes get oh so very much worse. Take it a step further. Now you have to store that data that's on your EBS volume in multiple places, assuming you care even slightly about durability, like 3 availability zones. So now you're spending 30 cents per gigabyte instead of the Object Store's 2.3 cents per gigabyte. But wait, it gets even worse than that. You have to pre-provision EBS volumes before you can use the storage, which inherently results in over-provisioning the volume because nobody likes a disk volume that's 100% full and paying a multiple of what your data storage costs. Lastly, you get to pay 2 cents per gigabyte every time data crosses an availability zone boundary. So assuming 3 availability zones, each gigabyte costs you an additional 4 cents in replication charges. So yeah, use object storage wherever possible. That's not viable for everything. Some things demand EBS volumes. I get it, that's okay, but take some time to figure out what your usage pattern looks like. You almost never want to be using IO1 or now IO2 volumes. If you see those volume types on your bill, it's usually a misconfiguration. It's faster than GP2, but that's usually not where you're smacking into limits. Instead, the bottlenecks that you're going to run into with GP2 are almost always an instance limit on EBS optimized volumes that you're going to hit first based upon the size, generation, and family of your instance. AWS has a whole ridiculous table of what these limits are. You can search for EBS optimized as your search term, and there's a page in their docs site that'll explain this out. And it's eye-popping if it applies to you. The bottom line is that there's invariably a lot of opportunities to explore storage optimization further. Just make sure you're aimed at the right problem before you dive into it. Getting rid of EBS and replacing it with S3 entirely is the right path in isolation, but there are always going to be constraints for when that won't work. If you've got another question burning on your mind, please reach out. You can find me on Twitter or other places where fine snark is sold. And of course, you can always visit us at duckbillgroup.com if you want us to really tear into a bill and do something horrifying with it.
This has been a Humble Pod production. Stay humble.